In inferential statistics, the term null hypothesis usually refers to a general statement or default position that there is no relationship between two measured phenomena, or no difference among groups, rejecting or disproving the null hypothesis, and thus concluding that there are grounds for believing that there is a relationship between two phenomena, is a central task in the modern practice of science, and gives a precise criterion for rejecting a hypothesis. The null hypothesis is generally assumed to be true until evidence indicates otherwise. In statistics, it is often denoted H0. The concept of a null hypothesis is used differently in two approaches to statistical inference. In the significance testing approach of Ronald Fisher, a null hypothesis is rejected on the basis of data that is significantly unlikely if the null is true, but the null hypothesis is never accepted or proved. This is analogous to a criminal trial, in which the defendant is assumed to be innocent until proven guilty beyond a reasonable doubt. In the hypothesis testing approach of Jerzy Neyman and Egon Pearson, a null hypothesis is contrasted with an alternative hypothesis, and the two hypotheses are distinguished on the basis of data, with certain error rates. Proponents of each approach criticize the other approach. Nowadays, though, a hybrid approach is widely practiced and presented in textbooks. The hybrid is in turn criticized as incorrect and incoherent. For details, see statistical hypothesis testing. Statistical inference can be done without a null hypothesis, thus avoiding the criticisms under debate. An approach to statistical inference that does not involve a null hypothesis is the following. For each candidate hypothesis, specify a statistical model that corresponds to the hypothesis, then use model selection techniques to choose the most appropriate model. Principle. Hypothesis testing requires constructing a statistical model of what the world would look like given that chance or random processes alone were responsible for the results. The hypothesis that chance alone is responsible for the results is called the null hypothesis. The model of the result of the random process is called the distribution under the null hypothesis. The obtained results are then compared with the distribution under the null hypothesis, and the likelihood of finding the obtained results is thereby determined. Hypothesis testing works by collecting data and measuring how likely the particular set of data is, assuming the null hypothesis is true. When the study is on a randomly selected representative sample, the null hypothesis assumes no relationship between variables in the population from which the sample is selected. If the data set of a randomly selected representative sample is very unlikely relative to the null hypothesis, the experimenter rejects the null hypothesis, concluding it is false. This class of datasets is usually specified via a test statistic which is designed to measure the extent of apparent departure from the null hypothesis. The procedure works by assessing whether the observed departure measured by the test statistic is larger than a value defined so that the probability of occurrence of a more extreme value is small under the null hypothesis. If the data do not contradict the null hypothesis, then only a weak conclusion can be made, namely, that the observed data set provides no strong evidence against the null hypothesis. In this case, because the null hypothesis could be true or false. In some contexts this is interpreted as meaning that the data give insufficient evidence to make any conclusion. In other contexts it is interpreted as meaning that there is no evidence to support changing from a currently useful regime to a different one. For instance, a certain drug may reduce the chance of having a heart attack. Possible null hypotheses are, this drug does not reduce the chances of having a heart attack, or, this drug has no effect on the chances of having a heart attack. The test of the hypothesis consists of administering the drug to half of the people in a study group as a controlled experiment. If the data show a statistically significant change in the people receiving the drug, the null hypothesis is rejected. Basic definitions. The null hypothesis and the alternate hypothesis are terms used in statistical tests. which are formal methods of reaching conclusions or making decisions on the basis of data. The hypotheses are conjectures about a statistical model of the population, which are based on a sample of the population. The tests are core elements of statistical inference, heavily used in the interpretation of scientific experimental data, to separate scientific claims from statistical noise. The statement being tested in a test of statistical significance is called the null hypothesis. The test of significance is designed to assess the strength of the evidence against the null hypothesis. Usually the null hypothesis is a statement of no effect, or no difference. It is often symbolized as H0. The statement that is hoped or expected to be true instead of the null hypothesis is the alternative hypothesis. Symbols include H1 and H. Statistical significance test. Very roughly, the procedure for deciding goes like this. Take a random sample from the population. If the sample data are consistent with the null hypothesis, then do not reject the null hypothesis. If the sample data are inconsistent with the null hypothesis, then reject the null hypothesis and conclude that the alternative hypothesis is true. The following sections add context and nuance to the basic definitions. Example: given the test scores of two random samples of men and women, does one group differ from the other? A possible null hypothesis is that the mean male score is the same as the mean female score. H0. mu1 equals mu2, where H0 equals the null hypothesis, mu1 equals the mean of population 1, and mu2 equals the mean of population 2. A stronger null hypothesis is that the two samples are drawn from the same population, such that the variances and shapes of the distributions are also equal. Terminology: simple hypothesis: any hypothesis which specifies the population distribution completely. For such a hypothesis, the sampling distribution of any statistic is a function of the sample size alone. Composite hypothesis: any hypothesis which does not specify the population distribution completely. Example: a hypothesis specifying a normal distribution with a specified mean and an unspecified variance. The simple composite distinction was made by Neyman and Pearson. Exact hypothesis: any hypothesis that specifies an exact parameter value. Example: mu equals 100. Synonym: point hypothesis. Inexact hypothesis: those specifying a parameter range or interval. Examples: mu 100, 95, mu 105. Fisher required an exact null hypothesis for testing. A one-tailed hypothesis is an inexact hypothesis in which the value of a parameter is specified as being either above or equal to a certain value, or below or equal to a certain value. A one-tailed hypothesis is said to have directionality. Fisher's original example was a one-tailed test. The null hypothesis was symmetric. The odds of guessing all cups correctly was the same as guessing all cups incorrectly. But Fisher noted that only guessing correctly was compatible with the lady's claim. Goals of null hypothesis tests. Statistical tests can be significance tests or hypothesis tests. There are many types of significance tests for one, two or more samples, for means, variances and proportions, paired or unpaired data, for different distributions, for large and small samples. All have null hypotheses. There are also at least 4 goals of null hypotheses for significance tests. Technical null hypotheses are used to verify statistical assumptions. Example: the residuals between the data and a statistical model cannot be distinguished from random noise. If true, there is no justification for complicating the model. Scientific null assumptions are used to directly advance a theory. Example: the angular momentum of the universe is 0. If not true, the theory of the early universe may need revision. Null hypotheses of homogeneity are used to verify that multiple experiments are producing consistent results. Example: the effect of a medication on the elderly is consistent with that of the general adult population. If true, this strengthens the general effectiveness conclusion and simplifies recommendations for use. Null hypotheses that assert the equality of effect of two or more alternative treatments, for example, a drug and a placebo, are used to reduce scientific claims based on statistical noise. This is the most popular null hypothesis. It is so popular that many statements about significant testing assume such null hypotheses. Rejection of the null hypothesis is not necessarily the real goal of a significance tester. An adequate statistical model may be associated with a failure to reject the null. The model is adjusted until the null is not rejected. The numerous uses of significance testing were well known to Fisher, who discussed many in his book written a decade before defining the null hypothesis. A statistical significance test shares much mathematics with a confidence interval. They are mutually illuminating. A result is often significant when there is confidence in the sign of a relationship. Whenever the sign of a relationship is important, statistical significance is a worthy goal. This also reveals weaknesses of significance testing. A result can be significant without a good estimate of the strength of a relationship. Significance can be a modest goal. A weak relationship can also achieve significance with enough data. Reporting both significance and confidence intervals is commonly recommended. The varied uses of significance tests reduce the number of generalizations that can be made about all applications.